Okay, friends, can't believe it, but this is the last lesson in derivatives. So let's get in. By this point, we are assigning every question in the coformative, and you'll notice that we have 2 days of review, and you can find wonderful, detailed solutions to the review made by Dana R. Dana A. So we're so thankful to her for creating that. And here we go. We're going to talk about higher derivatives. So today, once again, you're going to be reflecting on your thinking. So be ready to think, record, discuss, evaluate the thinking of yourself and others, the strategies, and also be open to extending the questions and posing new questions. And we're also going to demonstrate, develop, and apply conceptual understanding of mathematics through today, in particular, inquiry and problem solving. So demonstrate understanding through structured and guided open inquiry, which is basically what we do every day. So today is structured inquiry, and you're going to be using noticing and wonder, especially noticing and wonder today, to see if you can take next steps on these problems. Okay, so here we go. Alrighty, so we've been through all these rules, and now we are going to take a look at higher derivatives. So what would be the second derivative of this guy? Learning this notation, which is what's the value of the second derivative when x equals 2, and what would it look like to take the second derivative of this one, which would require implicit differentiation. So 3 tricky questions, and that's what we're going to look at today. Okay, so here we go. Let's go. So determine the second derivative of y equals x plus 4 to the power 4 minus 25x. I'd like you to pause the video right now and determine the second derivative on your own. And when you're ready to check, come back to me. Okay, so the first derivative I think we are all going to be okay with. We're going to use the chain rule here. So we're going to bring down the 4 to the power 3 and then multiply by the derivative of that guy multiplied by 25x, and the derivative of that would be 25. So I think you can see we're going to bring down the 4. The derivative of x plus 4 is 1, and the derivative of negative 25x is negative 25. And then we're going to take the second derivative, so the 2 will come down, so the 3 will come down to make it 12 to the power 2. And then the derivative of x again is 1, and the derivative of 25 is 0. So that's why we have 12 bracket x plus 4 squared. So there you go. Determine the second derivative of this term here when x equals 2. So again, why don't you pause this video, and I really want you to use your noticing and wonder before you take a look at my solution here. As you look at the first derivative, think what are all the things we might want to notice and wonder about, and then when we take the second derivative, pay close attention to see if you can spot the little tricks that you're going to need to apply. All right, so the answer is 146,064. Why is that? So let's take a quick peek. So first derivative, pretty straightforward. We're going to use the chain rule. So the 3 comes down, multiplied by the internal term to the power 2, and then the derivative of the internal piece is 4x cubed. I am going to sort of collect like terms here. Not like terms. I'm gonna put the monomials up at the front, so we're gonna have it like this. So this is just good habit always to do that. And now what we're gonna do is we're gonna say we need to take the derivative of this guy. And lots of room to make silly mistakes here. Here's a great silly mistake waiting to happen. This would be 36x squared multiplied by 2x to the power of 4 plus 1 to the power of 1 and multiplied by 4x cubed. Friends, can you spot my error? And I'm sure you're going to say, T-Spray, where is the product rule? Because this is F and this is G. So that part was okay, but that's F prime and we need to multiply by G. So all of this is bad. So let's look at the truth. So we're lined up right there. And now remember, here's F, here's G, here is F prime, here is G, here is F, and all this business right here is G prime. So be really careful here. It'd be really common for you to stop and not notice and not wonder or not reflect and think, am I making sense? So that would be the task at hand. Now at this point, we're going to try to figure out the second derivative when x equals 2. So you could combine terms here. You could factor out this, or you could just simply substitute. And notice that I did that. I put these guys together, which is probably good form. It is good form. We could factor that fully, or we could simply put 2 in wherever we see the x's, which is what I did. And I think you're pretty good with your calculator. So there you go. That is challenge 2, and definitely a tricky question. This one here is the one that I really want you to focus on using your noticing and wondering. Okay, so before you watch my clip, give this a go on your own. And what we're going to try to do is find the second derivative of x squared plus y squared equals 7. And I want you to simplify as much as possible. Okay, so put the video on pause and find out the second derivative, simplify as much as possible, and then after that I want you to determine what the second derivative is when x equals 4. Okay, pause the video and check in. All right, friends, welcome back. So we're going to take a look at this one, definitely a tricky question. First off, let's see how you did. That is the second derivative in the most simplified form. Okay, and we'll talk about a solution to that in just a moment. But before we do that, if we were trying to figure out if you got that far, then this follows simply, because if we have x equals 4, that would make this 16 minus y squared equals 7. So we know that this guy right here, 16 minus something equals 7, that must mean that y squared equals 9, which means that y must equal, y must equal plus or minus 3. And when you put plus or minus 3 inside there, you're going to get 7 over plus or minus 27. Okay, so we're going to clear that out. But this is the part that I think you're going to obviously have a bit of trouble with. You don't need any help substituting or finding x and y values. So we're going to try to find this guy here, and it is cheeky, it is tricky. But if you're noticing and wondering, you'll spot this. So again, if you haven't tried this on your own yet, please stop the video and try it. The curricular competency is using noticing and wonder to simplify as much as possible. You need to be curious here. You need to wonder, and that's the skill we're working on. All right, so here we go. X squared minus y squared equals 7, and there's a little sub in there. That's like one heck of a cute Bitmoji, and that looks a heck of a lot like me. So let's move on. So don't give up. The image below is a big hint. What could we possibly mean by that little submarine? And do it a lot. I really get the sense that we're supposed to substitute something. So let's take a peek here. So first things first, we're going to take the first derivative. So 2x to the power 1 minus 2y y prime equals 0. So that's implicit differentiation, which we have looked at. Now let's take a peek at simplifying for y prime. And so when I do that, I'm going to take I guess I took the 2x, negative 2x to the other side, and then I divided by negative 2y. And here's my first derivative. Now this is the first derivative. We're trying to find the second derivative. The second derivative, what we're going to use is we're going to use our good old-fashioned friend, the quotient rule. So there's f and g, and there's f prime g minus f g prime over g squared there. So that's what I've done. And at this point right here, you might wonder where we go. Let's notice and wonder. I notice that I have a y, an x, a y prime, and a y squared. And so I need to be noticing and wondering what am I going to do, because I have a y prime here, I have an x and a y squared. By now, surely we know that there's too many variables there. So if we can, write some in front in terms of others, that would be a really good thing. And we've done this a little bit as we've observed some of the proofs we've done. Actually, the proof for the quotient rule, we did this. Anyhow, when we see this little sub, is there anything we could sub for, the y, the x, or the y squared? I think you're probably going to notice that y prime we could sub something for. And there it is right there. That equals y prime. So I'm going to sub that in right now. Okay, so when I do that, I'm going to sub that in. Guess what we're going to do next? Well, we've got a complex fraction. So we're going to multiply top and bottom by y. And thank you for subbing finally. And so we're going to multiply the y through, which gives me y squared minus x squared over y cubed. Now, believe it or not, we can write this in a more simplified form. And it may not be obvious, And it might not be obvious to write it in that form either. So this is where noticing and wondering came into be, to place. So noticing and wondering helps us find things that aren't necessarily immediately obvious on the surface. We have to be persevere, and we have to be willing to explore and stay in the problem. Now, at this point here, we could write that another way. I want you to look at this screen really carefully and see if you can notice and wonder another way of writing this. And you know what? You might have been able to do it right here as well if you notice and wonder. And I'm really tempted to just click until the end and it says substitute. What could we possibly substitute for x squared minus y squared? Well, if you're kind of thinking, looking at this original guy here, man, that's pretty cool. So you can see that if we substitute if we substitute 7 for x squared minus y squared, we have our 7 over y cubed and negative at that. And there you go. So noticing and wondering would get the job done there. And don't be discouraged if you didn't see that, but then do reflect. What are your next steps? What are the next steps you need to take as you're reflecting and practicing your curiosity and your wonder? So we already spoke about this, but once you have this form here, another way of finding that is if you know what the x value is, we could put 4 in there, which would be 16. And we also learned that if we put 4 in here, that's going to make that 16, which is going to make this guy 9. Right? So 16 minus something equals 9. So if that's a 9, 16 minus 9 is 7. And that's where that 7 came from. And this 7, of course, well, it's the same 7. And then this piece down here, also notice this piece here, the plus or minus. You might wonder where that came from. Well, we know that this whole thing has to equal 9. So basically y squared has to equal 9. So we know that y would equal plus or minus 3, because 3 times 3 equals 9, and negative 3 times negative 3 equals 9. So this y value could be plus or minus 3, hence the plus or minus 27 on the bottom. So, woohoo! We're celebrating, friends. We're done. Again, take some time right now to look at the curricular competencies and wonder, where are you at on these? What are your next steps to continue to improve on these important skills? So I think we'll end this video here, and I hope that was helpful. Be sure to check out all the videos for this chapter, and you can find that on our slide deck.